Hello and welcome guys to this new video. In this video, I will be explaining you about binary tree, binary search tree and AVL tree. We are going to mostly learn about AVL tree, but before learning about AVL tree, we should know what is binary tree and what is binary search tree. So what is binary tree? Binary tree is a data structure. Here, each node can have at most two children. So this is a binary tree. It is an example of binary tree. Okay. What is binary search tree? Binary search tree is a binary data structure in which each node has at most two children, referred to as left child and right child. Okay, it is same as binary tree, but here's a change. Here, all nodes in the left subtree have values less than the node's value. Like this is a left subtree. Here, B is a left subtree, and here all values will be less than A. Okay, all the values in the left subtree will be less than A, and talking about right subtree, here all the values will be greater than A. That is, A is the root here. Root is the parent. Okay, and C and B are the child of root. Okay, so here I've written there B is less than A and C is greater than A. It means all the nodes are less than A in the left subtree, and all the nodes are greater in right subtree than the root. Okay, see for example here 5. 5 is the root, and all the nodes in this left subtree will be less than 5. See 2, 1, 3. All the nodes are less than 5. The values are less. Okay, and all the nodes in the right subtree will have value greater than the root. Okay, here first element is called as the root, and just one level down you will see the child of root, and two level down you can find grandchild of root. Okay, so we will be using this term, so keep in mind this all terms. I'll be revising it again, but you should keep that in mind. Moving to the next part, what is AVL tree? So AVL tree is the extended version of binary search tree. In this, we perform rotations to make the tree balanced. Okay. There are four types of rotations for inserting into node. Okay. There are also many rotations for deleting from the node. Okay. There are four rotation, that is left rotation, right rotation, LR rotation, that is left right rotation, RL rotation, that is right left rotation. Don't look to this now. I'll be telling you soon. So moving to the first one, left rotation. Before knowing about this rotation, you must be knowing about what is balance factor, what is acceptable range, what is critical node. Okay, these three terms you should be knowing. So before that, I'll be telling about this all. You can A is the root. You must be knowing that. B is the child of A and C is the grandchild of A. You can also call C as the terminal node or the leaf node because C is at the bottom. Okay, the most bottom, that is the bottom most node is all can also be called as node, terminal node or leaf node. Okay, it don't have any child elements. Keep that in mind. What is balance factor? How to calculate this balance factor? We can calculate this balance factor for each node. Node can have its own balance factor. Look at this 0, 1 and 2. It is the balance factor. So balance factor of C is always 0 because it don't have any child elements. Okay, child nodes. Balance factor is height of left subtree minus height of right subtree. Okay, height of left subtree, you don't have any subtree right or left, so it has balance factor 0. Looking to the B, we have one left subtree, that is C. So we have the balance subtree. We can find balance factor like putting here. Okay, height of left subtree, that is here height of left subtree is 1, and you don't have any right subtree, so height of right subtree is 0. So balance factor will become 1 minus 0 is 1. Okay, for A, you can count as we have in left subtree we have two nodes. Okay, 1, 2, we have two nodes. Okay, and in right subtree we have 0 nodes. So 2 minus 0 is 2. You this must be clear to you about this balance factor. Now what is acceptable range? When we get this balance factor, we can only have these values minus 1, 0 and 1. Any values greater or less than this is not acceptable, and we will consider that node as critical node. We will be calling the node as critical node while looking from the bottom only. Okay, so look from the bottom. that is C, B, and A. Here A is the first node getting our value balance factor. Other than this, okay. So it will be considered as our critical node. So here our critical node is A. So with respect to critical node, we will be looking. See, we will be looking to the tree and we will be adjusting the tree. We will be balancing the tree. We will be rotating the nodes. Okay. So we have added C here. Because of C, the balance factor has changed. Okay. I'll be explaining you when we add a node, then how balance factor changes. Okay. And what is the balance factor? If C is not there, you can call it as then at that time B will be the only element present here, A and B. So B will be having balance factor 0 and A will be having balance factor as 1, and there will be no critical node present. Okay. So in left rotation, see this child here. I mean that the root will be replaced by child. So what is the child of A with respect to critical node? Critical, what is the child of critical node? Who is the child of critical node? B is the child of critical node. So we'll be replacing root or the critical node with B to balance the tree. Okay. So B will be taking the place of parent or the root, and all other nodes will be adjusted accordingly. Okay. So what is A? What is the value of A? A must be greater than B or less than B. So it will be greater than B because all the elements in the left subtree are less than the root. Okay, less than the parent. They are less. And all the nodes in the right subtree are greater than the parent. So B is less than A. So A will be placed in the right side and C will be placed on the left side because C is the left subtree of B. So it is less than B. Okay, this must be clear to you. Now we are moving to the right rotation. So moving to next one, right rotation. In right rotation, we perform rotation with child element only. Child node, see this child node will be replacing critical node. Okay, this child critical node is A, and here child node is B because B is the child of A. So B will be replacing A to make the tree balanced. Okay, how we have calculated A as critical node? By looking into this balance factor. Okay, so we can calculate for C also. C is the terminal node, so it don't have any child nodes, so the balance factor is 0. For B, it has no node in the left subtree, so 0 minus 1. It has one node in the right subtree, so 0 minus 1 is minus 1. For A, in the right, in the left side it has no nodes, so 0. In the right side it has two nodes, so 0 minus 2 is minus 2. Okay, so here A has balance factor minus 2. This is not acceptable. We have acceptable range as minus 1, 0 and 1. Okay, so we will be replacing it. So B will be taking the place of A. A will be shifted to the left part and C will be shifted to the right part because here A is less than B. B is on the left, B is on the right side of A. So B is greater than A, and C is on the right side of B. So C is greater than B. Okay. So C is greater than B. So C will be placed here, and A is less than B. So it will be placed in the left part. Okay. So this must be clear to you. Moving to the next part. So our next part is left-right rotation. In left-right rotation, we replace critical node with grandchild. We replace critical node with grandchild. How we have got A as critical node here? So we can calculate it by calculating the balance factor. For C, C is the terminal node, so it has balance factor 0, obviously. For B, so B for B, it has no left nodes. Okay, so B has no left node, so it is 0. It has one right node. It has one right node, so 0 minus 1 is minus 1. Okay, now for A, how we can calculate for A? In the left part, in the left subtree, the maximum length is 2. Okay, so the maximum length is 2. Okay, the longest path, we have to see the longest path till the terminal node. Okay, till the terminal node we have to see the longest path. So there are two nodes in the left part, so 1 and 2, and has no nodes in the right part, so 2 minus 1, 2 minus 0 is 2. Okay, we have found the critical node, and the critical node is A. In this, in left right rotation, How we get to know that we have to perform left right rotation? Like we have added C here. Okay, C is added to the left and right part, left subtree and the right part of the subtree. Okay, the right part of the left subtree. Okay, so left right rotation, we have to perform left right rotation. In the earlier examples, we were adding C to the right and right part, and before that we have added C to the left and left part of A. Okay, so here we have to perform left right rotation because C has been added to the left and right part of A. Okay, so here we will be replacing critical node with the grandchild, and here grandchild of A is, that is, the grandchild of critical node is C. Okay, so C will be taking the place of A, C will be becoming the parent, and B and C will be adjusted accordingly. B will be less than C because C is on the right part of B. So B will be less. So we will be putting B on the left part. What about A? A is the parent. Okay, A is the parent, and all the nodes in the left part, in the left subtree, are less than the parent. Okay, so A is greater. So A will be placed in the right part of C. So moving to the next part, that is left right rotation. So our next part is right left rotation. In right left rotation, we replace critical node with grandchild, and here A is our critical node. We have calculated critical node by looking into the balance factor. We start calculating balance factor from the bottom. C's are the bottommost element, that is a terminal node, and it has balance factor 0. If we have calculated this because it do not have any left subtree or right subtree. It has left subtree as 0, no nodes, no nodes in the left subtree, so 0, no nodes in the right subtree is 0, 0 minus 0 is 0. For B, it has one node in the left subtree, that is 1, and 0 in the right subtree, that is 0, so 1 minus 0 is 1. For A, it has no nodes in the left subtree, that is 0, and it has two nodes in the right subtree, that is 2. 0 minus 2 is minus 2. If we have one more element here, and then at that time we can calculate balance factor for this as 1 and 2. That is 1 and 2, like we have to go to the longest part till the longest part for the terminal node. Okay, for the leaf node we have to choose the longest path. Okay, and that will be our balance, that will be our height of that tree. Okay, so 0 minus 2 is minus 2 for A. 2 is minus 2 is not acceptable because we have acceptable range as minus 1, 0 and 1. So A is our critical node. We have to replace A with the grandchild because in right left rotation we have to replace A. We have to replace with grandchild. How we have decided that we have to perform right left rotation? Because we have added C as our new element here, new node here. Okay, and C has been added to the right subtree and left of it. Okay, right subtree and left of it. Then so the because of that only we have to perform right left rotation. In the earlier examples we have seen that C has been added to the left subtree and right of it. Here we have added C to the right subtree and right of it, and in the first example C has been added to the left subtree and left of it. Okay, so in this way you can you will be clearly understood that which rotation you have to apply. Okay, so here C will be placed as our root element and A and B will be adjusted accordingly. C is on the left side of B, so in that manner B is greater than C. Okay, B is greater than C, so B will be placed in the right part. B is greater. Okay, A is less than B and C because A is the parent of B and C, and all the nodes in the right subtree are greater than their parents. Okay, so B and C are greater, so C is greater than A obviously. So A is less than C, A will be placed in the left subtree. I have tried my best, and I have explained all the topics from my side the best way. If you have any doubts you can comment down. I'll be replying you soon as possible.